Hi everybody, welcome to the LaserGlow Technologies how-to video series. Today we're going to learn how to install and align our LaserGlow multi-mode fiber coupler. The first thing you're going to want to do is to fix the laser head to the optical table. I'm doing that here with 2 hex screws. Next, you're going to want to remove the aperture cap, and that just screws off. There's normally a small ring on there that can stay on if you just screw it to the end. Now we're going to attach our fiber coupler, and that just screws onto the threading on the aperture tube, and you're just going to want to screw it on until it gets tight. There we go. Now we're going to remove the cap, and we're going to remove the front plate. And we do that by removing these 3 hex screws on the front plate. And I'll just put them to the side here for later. So now we have our front plate, and we're going to take our fiber cable. I'm using a 50 micron core FCPC armored cable here, and so we're just going to screw it on to the front plate. Now I'm attaching the other end of the fiber in a little stand, and I'm centering it in the center of our detector, so we can measure how much output power is coming from it. Then you reattach the front plate, but before you do that, we're going to need to put our safety glasses on, and you're going to want to make sure you have the correct safety glasses for the wavelength of laser you're using. And it normally says that on the front of the safety glasses. So now we'll turn our laser back on, and I'm going to very slowly align the front plate in the XY direction. The best way to do this is to move it in a raster scan pattern, and you're going to want to do this until you get the maximum output power you can. To get a better idea of what's going on inside the fiber coupler as we're aligning the front plate in the XY direction, we'll now take a look at a brief animation. You can see the beam strikes a focusing lens, which then focuses the beam down to a small spot, and you're trying to get that spot to align with the core of the fiber optic cable. You can see the front plate is moved back and forth and up and down until we get this spot in the center of the core. This will lead to the maximum coupling efficiency. And so you can see here I've got about 125 milliwatts. And the total output power of the laser is about 150 milliwatts. So now I'm going to need to align the Z direction to get a little bit more power. We're going to want to get the coupling efficiency up to at least 90% efficiency. To understand what's going on inside the coupler as we're aligning the Z axis, we'll now take a look at another animation. As the lens is moved forwards or backwards along the Z direction of the coupler, the position of the minimum spot size of the beam moves with it. If the lens is too close to the front plate, the position of the minimum spot size will be behind the fiber. As a result, not all of the light will make it into the core of the fiber, leading to an inefficient coupling. Similarly, if the lens is too far from the front plate, the position of the minimum spot size will be in front of the fiber. This will also lead to much of the light not making it into the core and an inefficient coupling. To maximize the amount of light that makes it into the core of the fiber, the lens should be moved along the Z direction so that the minimum spot size of the beam is in line with the front of the fiber. So to align the Z direction, I'm just going to adjust the lens inside the coupler, and I'll just give it a couple turns. And so now we'll put the front plate back on, and we'll see what kind of output power we can get. And so it looks like we were able to get some more power here. We're getting almost 140 milliwatts now, and that's over 90%. So now we can fix the front plate. To fix the front plate, we take the hex screws we screwed out earlier, and we'll tighten those back in. While I'm doing this, I should note that sometimes the XY alignment and the Z alignment will need to be repeated several times in order to achieve a satisfactory coupling efficiency. So for example, the first time you align the XY direction, you may only get 25% coupling efficiency. Then you'll adjust the Z direction and then get 75%. And then so you'll have to do that a third time in order to get the greater than 90 we're looking for. And we don't want to over tighten the screws at this point, so I'm going to loosen them off a bit. We want the front plate to be able to move around so we can still adjust the XY direction to get it back to where we need it. So you can see there's lots of movement here, so that's good. Now we just adjust the front plate like we did before in order to get the max output power. And so we've got about 48 milliwatts, so that's good. And now very carefully tighten the screws without ruining the alignment. And that's it, you're done. We hope this video gives you a better idea of the correct way to align your multimode fiber coupler. If you're interested in our multimode fiber coupling alignment services, please contact one of our qualified sales associates. To learn more and to see LaserGlow's full line of products, please visit www.laserglow.com.